my YouTube viewers. This is Crystal. In this video, what we're going to be talking about is smoothing techniques and time series analysis, because smoothing techniques are one of the methods that are used in time series analysis. So smoothing techniques and time series analysis reduce short-term noise so that underlying patterns such as trends or seasonality become easier to see. Smoothing helps reduce noise, highlight trends, and reveal seasonal patterns that may be hidden in volatile data. It is especially useful when data contain irregular fluctuations that obscure meaningful structure. So what I'm going to do is we're going to go over two small programs to demonstrate some smoothing techniques in R. I'm just trying to get, it's just being really slow. So we're going to talk about the simple moving average, SMA, which is a demonstration in base R. So it's going to show you the moving average program, which is one of the programs that, or one of the functions that you can use in R to smooth out the time series data. So the first thing that you want to do is you want to set your seed. And the reason why you set your seed is so every time you run the program, the variables will initialize to the same value. So you type set.seed 40 brackets 42, and you can type any number that you want within the brackets. And then so now what we're going to do is we're going to create some synthetic noisy data. So X becomes 1 to 100, and cells becomes 50 plus 0.3 times X plus R norm, that's a randomly sampled normal distribution, brackets 100, that's 100 samples, and a standard deviation of 5. So this R norm, your randomly sampled normal distribution, is the noise component of this time series data. So we're going to create a function to compute the simple moving average. So simple MA becomes function, bracket series, comma, window, and then it's going to be curly brackets, filter, brackets, series, comma, rep, that's repetition, brackets 1 divided by window, comma, size equals 2, and curly brackets, which is the end of the function. And now what we're going to do is we're going to compute the moving averages with different window sizes. So MA5 is simple MA with bracket cells, comma, 5, and MA10 is simple MA bracket cells, comma, 10, and MA20 is simple MA brackets cells, comma, 20. And then so your cells, we've already defined the cells function. So you've already got the cells function, and then that is your simple MA, the simple moving average. So we're going to plot the original data on a chart. So plot bracket cells, comma, type equals L, which lets you know it's a line. Color equals gray 40, comma, line width equals 2. Main is the title, which simple moving average is base R. Y lab is your label on your y-axis, which is sales. And X lab is your label on your x-axis, which is time. And then we're going to put 3 lines in the chart. So the first one is lines brackets MA5 which is going to be, it's going to smooth it by 5 units. Color equals blue. Line width equals 2. The second one is going to contain MA10. So you're going to smooth it by 10 units. And the color equals red. And the third one is MA20, which means you smooth it by 20 units and the color equals green. And then we're going to put a legend in there. So the legend brackets top left. So legend is a vector that says original MA5, MA10, and MA20. And your color is also a vector. So original is going to be gray 40, MA5 is going to be blue, MA10 is going to be red, and MA20 is going to be green, and line width is 20. Sorry, line width is 2. And then so we run the program, and then when you run the program, you can see you've got your original, which is gray, and it's got a lot of noise in it. So we're going to smooth it by 5 units, and that's going to be blue, and some of the noise has been taken out. We're going to smooth it by 10 units, which is red, and some more of the noise has been taken out. And then we're going to smooth it by 20 units, which is green, and you can see a lot of the noise has been taken out. So MA20 is probably the one that you're going to want to look at because it has most of the noise taken out of the program. So the next thing we're going to do is we're going to do exponential smoothing, and we're going to use the Holt-Winters function. So the Holt-Winters is a common function that is used in time series analysis, and you can use the Holt-Winters function in Python, which so you can use it in stats models. I believe it might be in stats models, or you can use it in SciPy or NumPy, but I think stats models is where you can find Holt-Winters. It's a very common exponential smoothing function. So the first thing we're going to do is we're going to set our seed. So every time you run the program, the variables are going to be initialized to the same value. So you type set.seed brackets 1, 2, 3, and you can type any number you want within the brackets. So we're going to create synthetic noisy data. So x becomes 1 to 100. Then we're going to have cells again. Cells becomes 50 plus 0.4 times x plus R norm brackets 100, and standard deviation is 6. So R norm is a randomly sampled normal distribution of 100 samples with a standard deviation of 6, and R norm is the noise that is introduced into the time series data. So now we're going to have simple exponential smoothing. So, and we're only going to use alpha. So beta equals false, which no trend smoothing, and gamma equals false with no seasonality. So your model becomes Holt-Winters bracket cells, comma, beta equals false, comma, gamma equals false. And then we're going to print the smoothing parameter alpha. So model $ alpha. And then we're going to make our fitted values. So fitted vals becomes model $fitted, square brackets, comma, 1. And then we're going to plot the original data and smooth series. So plot brackets cells, comma, type equals L, letting you know it's line, color equals gray 40, line width equals 2, main equals simple exponential smoothing and base R. X lab is the label on the x-axis being time. Y lab is the label on the y-axis being sales. You're going to put some lines in there. So lines, brackets, fitted vals, color equals blue, line width equals 2, and then we're going to put a legend in there. So legend, brackets, top left, legend is a vector that you created that says original exponential smoothing. Color is another vector that you created, so the original is gray 40, and the exponential smoothing is blue, and line width is 2. So we run the program. Excuse me. And then so we've got our model alpha, model $ alpha is 0.26. But we look at the chart that we plotted, and this is the chart that we plotted. So the original is gray, and you can see there's lots of noise in the original, and your blue is your Holt-Winters exponential smoothing, and you can see that the time series data has been smooth. So that's good. So there, in this video, we talked about 2 ways that you can smooth your time series data. One being the moving average, and you can determine how many units you want to average to smooth the data, and then you've got exponential smoothing, which is also Holt-Winters. So that concludes this. That concludes this particular video. The next video is we're going to be talking about ARIMA. So I hope that you decide to watch the next video, and I hope you got something out of this video. Thank you for watching.